Hello once again. In this video we're going to be covering dynamic memory allocation, but now for C++. Let's start by looking at a program that I pre-made. So here I start off by creating two pointers, a double called movie scores and an integer called I. Here I preset my values to the null pointer, which is this is a new term for you to learn. So in C, I would actually use the capital letters null, meaning this. I would be using that if this was C. But now that you're programming in C++, you need to use null pointer. And the reason that we use null pointer is that with the C style null, meaning use typing null in all capital letters, there can be an implicit conversion to an integer. And sometimes that's not what we want. However, null pointer will stay as a null pointer, a pointer to null. So we're able to avoid some accidental implicit conversions to integers. And while I think in the applications that you may be facing, it won't be such a problem. However, it looks good to use C++ tools in C++, and null pointer is one of them. So I have my two pointers. I set them both equal to null. And we'll include our dynamic memory allocation, in between line 5 and 7 right now. But here I have my safeguards, my if statement safeguarding that, okay, hey, if there's a problem allocating memory for this, we're going to print a message, and actually we'll return out of this. So here we'll have return -1, we'll have return -2. So why don't we go about doing dynamic memory allocation? So before, what we do is something like this. And this will be the way of the C version of doing this. But now that we're learning about C++, C++ has its own version of doing dynamic memory allocation, which I think is simpler. So why don't we see that? And here it is. So instead of using malloc and having some weird and esoteric inputs to the malloc function, instead of using that, I can just say new, which is a new C++ keyword. I have the data type that I want, and well, here I'm going to be creating an array of values. So I have an array of 8 doubles. I'm going to be dynamically allocating an array of 8 doubles. Well, now that I'm dynamically allocating here, I need to free the memory. So in order for me to free the memory, I'm going to go down here and I'm going to type the new delete keyword, and because it's an array, I'm going to include the square brackets. Right, so this is the way to do it. You can put a space in between, you can put it next to here. That's honestly fine. I personally like doing it this way, but that'll be up to you. But here, we're allocating memory for an array. What about a singular variable? Well, let's look at the case for I. Here is just how we allocate dynamically memory for a singular variable. Right, so here we have an array of variables, and here we just have one singular variable. So we'll need the new, the data type that we want to allocate memory for, and if it's an array, we're going to include the square brackets with the number of values we want to allocate for. If it's just a singular variable, having something is just new, and then the data type is okay. And this doesn't only apply to primitive data types like integers, doubles, floats, and characters. This can also apply to other variable types like strings, vectors, structures that you can define, and as you'll learn in the future, classes that you can define. As long as it's a properly defined data type, you can dynamically allocate for it. So now that I have allocated for I need to free that memory. And it's actually simpler than freeing movie scores, because I just need delete I. And that should be it. So here I have allocated dynamically memory for my variables, and here I free it. So the new keyword kind of acts like malloc, and the delete acts like free. Now that I have my proper safeguards for allocating, deleting memory, as well as checking if I had problems allocating for that memory, we can move on with the rest of the program with what we want to do. And here is the meat of the program. So simply, I'm going to ask the user to enter 8 scores. I'm going to have a for loop, and yeah, I made this a little bit more complicated than it should have been. But here I'm totally using dynamically allocated memory, so because of that I need to dereference I for every time, and actually this needs to be dereferenced as well. So I need to dereference I++. And actually, just to be safe, I'm going to say I plus equals 1, just because I know that it'll dereference first before incrementing. So yeah, what I do here is that I start from 0, I go until 8, and I go up by a value of 1. So here I read in some values, and because movie scores is a pointer, I need to dereference it, and because I'm using it like an array, I need to give it an offset. So movie scores will serve as like the movie scores of 0 plus an offset. That offset usually is just a normal I, but because I is a pointer, I need to dereference it to get that value. And this total offset of the address I need to dereference to get the value of scores. So I read that in using cin, and then once I'm done reading in all those values, I use the same looping mechanic to read out those same scores, separated with a space, and I print a new line. Once that is done, all my dynamically allocated variables are deleted, and we're good to go. While in this example it would be much better to use a vector, here I would like to showcase how you can use dynamic memory allocation. So let's see what this program looks like in execution. So here we are at the execution. It turns out I need to update the standard of the C++ that I'm using, so that way null pointer can be included while it is declared. So to get my program to compile, I had to use this statement rather than the typical GCC. So now that the program is running, let's enter 8 scores. So here I've entered my 8 scores, and cin will read them out, and cout will print them all back out. And it's all in the same order without the data changing at all. And at the end of this, because of the delete keywords, the memory will be free. So our last test will be to run this with valgrind. Oh wow, so I'm really surprised at this. It turns out that here when I run valgrind and I do, well, when I first did the leak check up here, it says that it's not definitely lost or indirectly lost or possibly lost, but it turns out almost 19 kilobytes are still reachable, which is pretty weird. So I reran valgrind with this leak check and show leak kinds at all, which we can see down here, and here this shows some extra stuff, and this shouldn't really matter too much if you don't know assembly and how to disassemble your executables, but it looks like there's a function called Dynamically somewhere inside of here, and it's not in main. So what I'm trying to say is that it's not my fault. So it's not in main here. If I were to change this up with let's say not freeing up I, this will be the result. And here it is. We see right here 4 bytes have been lost in new and in main, right? So this is the name. Here's my executable. So this shows that right here, okay, yeah, this is all totally my fault. But this, man, I have no clue where this is from. So I hope this convinces you that we've properly allocated memory for and have freed this data. Because when I forget to delete, I definitely lose these 4 bytes. Well, these, I don't know what's happening. But anyways, this is an introduction to dynamic memory allocation, how it works in C++. It shows I wanted to introduce the new keyword as well as the delete keyword here.